Okay, so we now deal with the harmonic mean, and we write that this is the mean of the reciprocals. This is the mean of the reciprocals. It's the mean of the reciprocals. Is the mean of the reciprocals, full stop. For ungrouped data, harmonic mean is equal to n out of sum of 1 out of x. For ungrouped data, so example is if you have a data set of 5, 4, 3, 8, harmonic mean will be these values. Let me put some other values. 9, 12. So there are 6 of them. So it will be 6 out of 1 out of 5 plus 1 out of 4 plus 1 out of 3 plus 1 out of 8 plus 1 out of 9 plus 1 out of 12. So that is how we compute the harmonic mean. So compute that and send me the answer. So give me the answer. Yeah, 5.44. 5.44. That's the answer. Then we write that when the data is grouped, harmonic mean is equal to sum of f. You divide by sum of f out of 1 out of 6. Sorry, 1 out of x. When the data is grouped. So this one I'm not going to compute. I'm not going to compute. So down there, Adika, harmonic mean is based on all values in the data. Harmonic mean is based on all the values in the data and is not affected by extreme values. It's based on all the values in the data and is not affected by extreme values. Full stop. However, it is not often understood. It is not often understood. And the purpose for computation is unknown. The purpose for computation is unknown. The purpose of computation is unknown. Yeah, so that is about the harmonic mean. And we are saying that it is not something that we are well aware of. And that's why we do not compute so much. Whoever came up with it is not very clear why they came up with it. So that is all about the measures of central tendency. The measures of central tendency. So let's go to the next category. The next category, which is known as measures. Measures of dispersion, stroke risk, stroke variation. Measures of measures of dispersion, risk, or variation. And we write that this is a measure that shows the spread. This is a measure that shows the spread. That is how far a particular value in a data, how far a particular value in a data set, is from the mean. How far a particular value is in a data set from the mean. Full stop. There are various measures as discussed below. There are various measures as discussed below. Number one, naitwa range. Range and we write that this is the difference between the highest and the lowest value. This is the difference between the highest and the lowest value in a set of data. The highest and the lowest value in a set of data. So that is R is equals to maximum value less minimum value. Maximum value less minimum value. So in an example, if you have minus 12, you have minus 8, you have 3, you have 5, you have 18. Range, we are saying is max minus min. So the maximum is 18, you minus 12. That should be 30. Then we write when the data is grouped, range is equal to upper limit of the last class, upper limit of the last class you minus the lower limit of the first class. If the data is grouped, now when you compute the range, get the upper limit of the last class, of the highest class, you less the lower limit of the first class. So if we have an example here, whereby we have the class of 1 to 8, 9 to 16, 17 to 24. Range will be equal to 24 minus 1, that is 23. So if you are given a data that has this kind of classes, and they want you to get the range, you get the upper limit, this one, of the last class, less the lower limit of the first class. So that is as simple as that. Number 2 is called mean absolute deviation. Mean absolute deviation. Mean absolute deviation mean absolute deviation, and we write that this is a measure of dispersion. This is a measure of dispersion that takes into account all the data values in a set. That takes into account all the data values in a set to determine the degree of variation. To determine the degree of variation in absolute values. The degree of variation in absolute values. In absolute values. That is taking all values as positive. Taking all values as positive. That is taking all values as positive. For ungrouped data, mean absolute deviation is the sum of xi minus x bar absolute, you divide by n. When you put it inside these two strokes, it is read as absolute. The sum, this sign is called sigma, means sum of the xi's minus x bar. So example one, you are given data here. You are given 3, 4, 8, 12, 17. You are given that set of data. Now the first thing, because this is ungrouped, we get the mean. We get the mean. We get the x bar. Now the X bar, we are going to get it as 3 plus 4 plus 8 plus 12 plus 17. Divide by 5. These values are 5. Get the answer. $5.44. Is it 5.44? Oh, okay. 8.8. 8.8. Okay. So if 8.8, Ivarin, I hope you can hear me now. Naona kama ulikuwa umeandika message that you could not hear me. Are you able to hear me now, Ivarin? Yeah, I can see even you have given the answer. That's good. Haya, so if you are told to get xi minus x bar, xi minus x bar, utakuwa unasema 3 minus 8.8. Tell me that is what? Three minus 8.8. Negative 5.8. 4 minus 8.8 would be negative 4.8. 8 minus 8.8 will be negative 0.8. 12 minus 8.8 So 12 minus can see 3.2. 17 minus 8.8. 8.2. Now, if you want it as absolute, xi minus x bar absolute, that way, if you want it as absolute, what you do, you ignore the negative signs. You take them as if they are positive. So sasa hapa tutaandika ni 5.8, hii ni 4.8, hii ni 0.8, hii ni 3.2, na hii ni 8.2. So give me this total. Give me the total. When we have ignored the negatives. Total. Waiting for the total of these ones as positive values. 21. So if it is 21, then down there, the mean absolute deviation will be 21 divided by 5. the mean, or I'm told is 22.8. 22.8. So this then will be 22.8 divided by 5. 22.8 divided by 5. So 4.56. 4.56. So that is how you get the mean absolute deviation. The mean absolute deviation. So assignment. Compute mean absolute deviation for. You have 5, 8, 12, 20, 29. So you can compute that later on your own. The mean absolute deviation. So down there we write, we continue after you have allowed the space, acha ka space that you think itatoshea, guided by the one we have solved together. So you write that when the data is grouped, the data is grouped, mean absolute deviation will be equal to, sum of f absolute x minus x bar, you divide by sum of f. Divide by sum of f. This time is moving very fast. Okay. So that is how we are going to go about it. So if we give ourselves an example, in this example, we will have the class here. Obviously, we will have the midpoint, which will be our x. Then we will have the frequency, which is our f. Then we will have a column where x is subtracted by or x bar is subtracted from that. And then the last column is f multiplied by the absolute x minus x bar. So we are going to have a table of that design. So if this is what? This is 1 to 4, 5 to 8, 9 to 12, 13 to 16. We are given something like that. Obviously, the midpoint here will be 2.5. This one is 13, so that will be 6.5. This is 21. That will be 10.5. This will be 29, so that will be 14.5. So if this is 8, this is 16, this is 12, and this is 4. Oh, I needed to create a column for fx. I needed to create a column for fx. I don't know whether you're able to adjust that. But now that I did not create it, it's not a big problem. So first of all, give me the total of this. I needed to have created that so that we compute the mean. But now that I forgot, taendelea tu. Give me the total of the frequencies. The total of those frequencies. 40. So if it is 40, below that now, andika x bar, you know the formula is sum of fx, you divide by the sum of f. That is the formula of getting the mean, the arithmetic mean. So now that we did not create a column to multiply, we just multiply here. 2.5 times 8 plus 6.5 times 16 plus 10.5 times 12 plus 14.5 times 4. Then you divide here by 40. The frequency values have been assumed. I'm assuming them, Ibarin. Those ones have been assumed, just like I've assumed the class. So give me the mean there. $7.7. So if the mean is 7.7, if the mean is 7.7, now let's get the absolute. We have here 2.5 minus 7.7 is what? 2.5 minus 7.7 is what? Negative 5.2. But because it's absolute, we just write 5.2. Because it's absolute, we are not recognizing the negative. Tell me 6.5 minus 7.7. 6.5 minus 7.7. 1.2. It's negative, but now tutaandika as positive. 10.5 minus 7.7. 2.8. 14.5 minus 7.7. 6.8. Good. So now give me the total of this. Oh, we don't need the total there actually. We don't need the total. Don't need the total there. Let's just go straight and multiply. Tell me 8 times 5.2. 8 times 5.2. 8 times 5.2, 41.6. 16 times 1.2, 16 times 1.2. 19.2. 19.2. Hiyo ingine, give me the value. This one, 12 times 2.8. And when you get logged out again, you will log in. I hope this time round haitasubua. 12 times 2.8 is what? 33.6. 33.6. 4 times 6.8. 4 times 6.8 is 27.2. 27.2. Now give me the total of this one. Give me the total of that. $121.6. 121.6. 121.6. Okay, so that means now the mean absolute deviation. The mean absolute deviation should be equal to 121.6. You divide by the sum of F, which is 40. Which is 40. So we have 3.04. 3.04.